Repainting your entire screen on every state change would make React unusable. So React doesn't. Every render, it builds a virtual copy of your interface and compares it against the previous snapshot. That comparison is called reconciliation. It finds exactly what changed, and only those changes reach the real document object model. The algorithm doing this can update one row in a list of 1,000 without touching the rest. Comparing two trees naively is a cubic time problem. For a tree with 1,000 nodes, that's 1 billion comparisons per render, completely unusable at scale. React's team solved it by making two assumptions. First, elements of different types always produce different subtrees. Second, developers can label stable list children with a unique key prop. Those two assumptions reduce the problem to linear time. React walks both trees simultaneously, starting at the root. If an element's type changes at any node, React tears down the entire subtree below it. A div becoming a section wipes everything underneath, nothing gets reused. If the type stays the same, React keeps the node and only updates the attributes that differ. Changing a paragraph tag to a heading tag remounts every child, even if none of those children changed. List rendering is where reconciliation gets expensive fast. Without keys, React matches children by position. Add one item to the front of a list, and React thinks every item shifted. It re-renders them all. With stable, unique keys, React tracks identity across renders. It knows exactly which node is new, which moved, and which stayed. Using array index as a key defeats this entirely. The key follows position, not the item. React 16 replaced the original reconciliation engine with a complete rewrite called Fiber. The old engine processed the entire component tree in one uninterrupted synchronous pass. It couldn't stop, yield, or prioritize. Fiber breaks rendering into small units of work that can pause and resume. This unlocks concurrent mode. React processes urgent updates like keyboard input first, then picks up heavier renders when the browser is free. If your component re-renders more than expected, the problem is almost always props. A new object literal passed as a prop triggers a re-render every time. React pairs props by reference, not value. Use React.memo to skip re-renders when props haven't changed. Use useMemo to stabilize expensive computed values. Use useCallback to stabilize function references. These aren't micro-optimizations. They're the direct consequence of how the diffing algorithm works.